Let's say for example, we are trying to do something like a ripple carry adder, correct? Let's say for example, I'm going to add two numbers. Ripple carry adder. I'm giving this as an example. It's also called as a RCA. Okay. Now how do we add? Let's say for example, we have to add two numbers. How do we add? Let's say I need to add two binary numbers. How do I add? I will add these two. 0 plus 1 is 1. And if there is any carry, I will carry it forward. Correct. If there is no carry, I will not carry. 1 plus 1 will give 1. Sorry, 0, 1. Again, 1 plus 1 will give 0. And there is output. This is how I will get, correct. So the carry ripples from the input all the way till the last. Say for example, I'm adding this. 1 plus 1 is going to give you 0. I will get 1. Now this 1 plus this carry 1 will become 0. Again there is a carry generated here. 1 plus 1 will become 0 and 1. So the carry sort of ripples through from here. Correct. That's why we call it as a ripple carry addition. Okay. So now the hardware of this is going to look something like this. I will have full adders which is capable of doing 1 bit addition, multiple full adders. Okay. And let's say I'm trying to add these two numbers, right? So whatever may be this, I'm calling this as a num1, I'm calling this as num2, and these are the bits 0, 1 and 2. So here this is the input carry that in the input stage. First stage doesn't have any carry, so I'm grounding it off. This will be num1 of 0, num2 of 0. So it gives a carry and sum. This carry will ripple through, correct? And I will get num1 of 1, num2 of 1. Again there is a carry and a sum. This carry will ripple through. I will have num1 of 2 and num2 of 2. I will have the sum. I will have the carry. So this together will make the sum 0, sum 1, sum 2. I can call this as sum 3 or the output carry, whatever name I want to give. So here I have to instantiate the same full adder multiple times, 3 times here. If I have to do a 8-bit addition, the same full adder has to be instantiated 8 times. If I have to add 128-bit number, the same full adder has to be instantiated 128 times, correct? So clearly, there may be a need. This is just an example. There may be a need. Clearly, a single hardware may be instantiated multiple times. So we use for generate. Similarly, like for generate, I can use a if generate also. If some condition is met, generate the hardware, otherwise don't generate. So I can use if generate also, for generate also. But kindly note, for generate and if generate are used outside the always block. Generate is always used outside the hardware, always block, and it is for replication of hardware. Okay. So quickly, we have to summarize. So quickly, if you have to summarize, we saw the for and for generate. Okay. Clearly, for is used inside always. This is used outside always. For is used for multiple evaluations. Okay. This is not used for evaluation. This is for hardware replication. Clear? This is not for hardware replication. For is not for hardware replication. Clear? With this, we conclude this session. Thank you. In the subsequent session, we will see the lab for this. Thank you.